All right. Hello. I'm Eric Keller from the University of Colorado, and I'm here to talk about Disguise, 5G privacy with vSIM. So I'm a professor. My students couldn't make it, but acknowledge Shirin and Zach's work. All right. So this work is concerned with pattern of life analysis. So this is a method of surveillance that documents or understands the habits of a person or population. And cellular communication presents a unique privacy concern in that both your online and the physical, meaning your like location, your activity, are observable by the operators. So traffic in 5G is encrypted, but there's a lot of metadata and information about what you're doing that is observable. So going, kind of through this, first, is your traffic. As I said, it is encrypted, but the headers, the patterns, the kind of the sizes of the packets and the timing of them really can be used to expose who you're communicating with, what activity you're doing, and so forth. And so there are defense mechanisms such as VPNs and traffic obfuscation that exist. Next up, we have the subscriber profile. So this is, what gives you, a phone number that what allocates, kind of or associates a billing address or billing information with you. And so this allows the operator correlate, various different traffic to a particular subscriber. So one, defense is you could, phones nowadays have kind of eSIMs so that you can swap out your subscriber profiles. And then there's been some academic work towards anonymization of these subscriber profiles, and I'll list a few there. All right, moving down the stack, we have the IMEI. So this is an identifier on the modem. So much like a MAC address in Ethernet, and this can bind a subscriber profile to a particular device. And there's been, defenses to, kind of work around this, and I list a couple there. So what's missing? The, in our work, we kind of found that there's this still a problem of linkability through the SIM card. So even with all of these, kind of previous mechanisms, an operator can still link various subscriber profiles to the same device due to the SIM card. So a SIM card has an embedded, it has some, identifiers on it, the embedded identity document, and it has a secret key on it. So these are provisioned by a manufacturer. It's shared with the operator. It's not changeable. It's not readable. But the whole authentication process in 5G networks depends on this link between the subscriber profile and the EID and this secret key. So what Disguise is an approach to breaking this linkability. So effectively, we want to move the SIM into software and enable dynamically provisioned device profiles. So not the subscriber profile, but kind of this hardware, level identifiers, the EID and secret key, all while retaining backwards compatibility. And kind of the contribution or the novelty here is really overcoming 5G's implicit trust that relies on, the physical nature of the SIM coupled with business relationships. So another way to think about kind of our goals is to, with a single phone, to make it look like you have multiple burner phones. All right, so here is a picture of our architecture. I'll go through the kind of four key aspects of this in the subsequent slides, but just to kind of orient you on what you're seeing in this picture. On the right-hand side is the provider. So this is the cellular operator, all their software, the base stations, and so forth. On the left-hand side is the user equipment or your phone, and we'll go through kind of each piece. All right, so the first challenge to overcome is how to keep the secret keys secret in software. So in the current approach, this is embedded in the hardware. It's not readable. So it's, kind of trusted by design. And now we're saying, hey, let's put that in software. And that, kind of inherently, puts those values that are supposed to be secret at risk. So the first part of this architecture is making sure we leverage trusted execution environments. So our vSIM, which is what we call this, runs inside of a trusted execution environment, which is pretty prevalent in just about all architectures. Like ARM Trust-Own is a popular one. All right, so the next is now how do we establish initial trust in the SIM? So again, the current method is these business relationships between a manufacturer and an operator. We kind of have a similar thing here in that the hardware manufacturer does exist. We don't want it to tie back to a single, device, and instead we kind of leverage the concept of group keys, which allows for this trust. Trust the hardware while remaining anonymous. You couple that with secure boot of the vSIM software, and now we have this known stack of the hardware kind of through the SIM functionality. The third piece is now how do we provision those device profiles, all right? And so here, what we need is, so there's not this business relationship that exists, and the provider on the right-hand side doesn't necessarily need to be the network operator, could be a third party, wants to install one of these device profiles, but they have to be able to trust, like, hey, you are using a trusted execution environment, prove it to me, prove that you're running the software that's known. So we, introduce, or describe a protocol that can establish a secure channel, and then leverage remote attestation to be able to verify to the provider that this is, a known software stack, and then they can, and hardware stack, can then install this profile. And then the last piece is dynamically provision the authenticated and authenticate the subscriber. So this is, kind of what you want out of 5G. You want to be able to connect to a network. And it says innovation, but there's really no innovation. It was basically to just made sure to make it all backwards compatible. So once you have, this device profile, all this software stack, so we leverage kind of open source, kind of 5G implementations, and validated that we can do all this without modifications. All right. With this, we then wanted to evaluate. And so the kind of key evaluation, what are we after is kind of privacy, I guess. And so it's really, if we can modify, that device profile, can I have different traffic on different profiles and make it so that an operator cannot say, hey, both of them belong to the same person. So this data set does not exist, or at least, we couldn't find any for 5G traffic. There was one in Usenix security that was more like a campus network, where you have like dynamic IP addresses, and they were, said, hey, we can actually correlate different traffic to the same, that have different IP addresses that are actually the same device. So we use that as a proxy of data set, and basically demonstrated that with vSIM and with obfuscation, we can bring down, the kind of correlatability, or linkability, whatever you want to say, between, various subscriptions, to, kind of below 50%. So you're basically guessing at that point. So with that, we introduced Di5Guise to significantly impair the ability of network operators to link various subscriber profiles. And you can see me in the break, where we'll discuss, this was all built with like an FPGA based prototype and go through it. So with that, thank you.